Now let's take a look at one more question. All right, well, maybe two more, and then we'll switch to another video. So there's another MC question. We have a $1, $1 coin, $2, $1.5, and $1.10. All right. Christine takes out 3 coins randomly from the pocket. Find the probability she get at least 13,000. All right. So now first of all, is it dependent or independent? Is it with replacement or without replacement? Think about it. It's not mentioned in the question, right? You have to think about it from the context. He takes out 3 coins randomly from the pocket. All right, that means the coins are taken out at the same time. Am I right? There is no replacement at all. They are taken out at the same time. Right? She just grabbed 3 coins out of her pocket. So the coins, they are taken at the same time. So that means it is without replacement. Alright, you must understand this. It is not mentioned directly in the question, but it is in the context. Alright, if the 3 coins are taken out at the same time, it's without replacement. Alright, let's see. How do we have 3 coins to make the sum at least 13? Alright, we need 10 and a 5 and a 1, alright, and a 2, right? That is the largest, 17. We have a 10 and a 5 and a 1, alright, 16. We have a 10 and a 2 and a 1, alright. These are at least 13. Alright. Well, there is one more way. You can have the 5 and a 2 and a 1, alright. That would be less than 13. Alright. These are the only 4 ways you can pick up the 3 coins. Alright. So that means, what does that mean? That means unless, alright, unless it is $5 to $1 combination, the probability of at least 13 means that it is the probability of unless it is $8, alright, and $8 will be 1 minus the probability of $8, and $8 will be the probability of getting the 5, the 2, and the 1, alright. Am I right? At least 13 means unless you get $8, unless is 1 minus, unless is 1 minus, alright, the probability of $8. So how do you get $8, right? $8, maybe you do that. First you pick the $5, so that is 1 over 4, right? Among the 1, 2, 5, 10, alright? You pick the 5 is 1 over 4. And then it's now down to 3 coins. You pick the 2, that is 1 over 3. Alright? It's now down to 2 coins. You pick the 1 is 1 over 2. Alright, so that is 1 over 24. The answer will be 1 minus 1 over 24, and that is 23 over 24. There is an answer here. But no, it is wrong. It is wrong. Alright? I missed something here. It's wrong here. I missed something. What did I miss? Think about it. What did I miss? Alright? The probability of getting the $5 will be the probability of getting the $8 will be $5, $2, and $1. So $5 is 1/3, 1/4. Sorry, $2 is 1/3, and $1 is 1/2. So what did I miss? What did I miss? What did I miss? I missed the blue number. This 5, 2, 1 branch is going to repeat several times. I missed the blue number. Alright, I have to think about in how many ways this 5, 2, 1 can make it into the tree diagram. Alright, you can have 5, 2, 1, you can have 5, 1, 2, you can have 2, 1, 5, 2, 5, 1, and 1, 2, 5, and 1, 5, 2. Is that all? Is that all? Now we can do this, right? That is a manual counting of the number of ways. Alright, multiply to 6. Multiply to 6, alright, and the correct answer goes to 1 minus 6 out of 24. The answer is 3/4, 3 over 4. This is the correct answer, alright, 3/4, not 24 over 20, not 23 over 24, alright, because of the blue number here. This is the most crucial number in the entire question, alright. Now, instead of manual counting, you can use permutation, right? You know what you are doing here in this blue box is I am permutating three numbers. To permutate three numbers, the number of ways to do that is 3p3. 3p3. It's not a combination, it is a permutation. You are permutating three numbers, 1, 2, and 5. Alright, so you can pick a 5, you pick a 2, and then pick a 1. Now 5, 2, 1, what does that mean? That means the tree diagram is 1, 2, 5, 10. Alright, and then from the 5 you can pick up 1, 2, and 10. From the 2 you can pick up 1 and 10. We are talking about this particular branch. 5, 2, 1. This will give you $8. Alright, but it is not the only branch that will give you $1. This 1, 2, 5 branch will also give you $8 and so on. Alright, there are 6 such branches, 1, 2, and 5. Alright, as you can see here, there are 6 such branches going 1, 2, 5. Alright, so you have to multiply that to 6 because that 1, 2, 5 branch is going to repeat itself 6 times. Alright, so the answer is 3/4. Okay, the last question here. We have 5 red, 6 yellow, and 3 whites. Alright, if 4 balls are randomly drawn at the same time, now pay very particular attention, right? At the same time, without replacement, dependent events. Okay, now we have 3 colors: 5 red, 6 yellow, and 3 whites. Alright, what is the probability that exactly 2 red are drawn? What is the probability that at least 2 red are drawn? Alright, the only difference between part A and part B is the keyword exactly and at least. Alright, exactly 2 means exactly 2, right? You draw 2 red, and then that's very complicated. It's 2 red, 1 yellow, 1 white, or 2 red, 2 yellow. Alright, can we do that? We can have 2 red, 2 whites. Alright, right, you can think about this. Exactly 2 red will be something like this: 2 red, 1 yellow, 1 white, or 2 red, 2 yellow, or 2 red, 2 whites. But wait, now you spend too much time if you think about it this way. Let me ask you the question again. How many colors are there in this box? 5 yellow, 5 red, 6 yellow, and 3 whites. How many colors? It's not 3 colors. There are only 2 colors. Namely, that one color is red, the other color is not red. Never mind they are yellow or white, I don't care. Alright, there are only 2 colors, red and not red. Alright, don't try to distinguish into yellow and white because the question is only concerned about red balls. It has nothing to do whether it is yellow or white. Alright, so think about it. Alright, the box, there are 5 red and 9 non-red. Alright, let me put a cross on top to indicate it is a non-red. The box consists of 5 red and 9 non-red. Never mind they are yellow or white, I don't care. Alright, so to have exactly 2 red balls, we have, the probability of exact 2 red will be 2 red, right? Red and red. So the first red is 5/14. The second red is 4/13, right? Now that would be wrong. That would be the first mistake here. Right, let me recall. That would be the first mistake here. Okay, it's not like that. If it is exactly 2 red, because 4 balls are drawn, alright. So exactly 2 red means that 2 of them they are red and 2 of them they are non-red. Alright, the probability of 2 of them they are red, 2 of them they are non-red. Alright, so 2 of them they are red, the probability will be 5/14, 4/13. Alright, the first red, the second red. And then the third one is a non-red, it is 9 out of 12. The last one is non-red, so it's 8 out of 11, right? So if you multiply all this together, that is the answer. Alright? Not quite, this is not quite the answer. Right? What did I miss? Once again, I missed the blue number. This 2 red, 2 non-red branch is going to repeat itself. But how many times? Alright, think about it. We can have 2 red, 2 non-red. Alright, we can have wow, it's once again quite a bit of counting to do. You can do it manually like what I'm doing here now. Alright, to put 2 reds and 2 non-reds, we can have this. What else? We can have the mirror image. Alright, this one, and then we can have this one. And oh, I missed something. No, you can see it. Alright, and then we can have this. Alright, is that everything? Alright, to put 2 reds and 2 non-reds in 4 bowls, we can have this. Alright, that is altogether there are 6 of them. Alright, let's multiply to 6. Now I just did it with manual counting. Alright, but you can also think about it with NCR or NPR. In this case, you are putting 2 reds into 4 positions. So this number 6 comes from 4C2. Alright, I know it's very confusing. This time we use 4C2. Just now I use 6. I use 3. Alright, so sometimes it's P, sometimes it's C. Alright, honestly, there is no easy way to tell whether we should use permutation or combination. You have to think about the situation and see whether you should use combination or permutation. In this case, it is just like 4 positions. We put 2 of them to be red. Alright, so we choose 2 of the chairs to put the red color. The other 2, they are automatically not red. Alright, so that means we have 4 chairs. We choose 2 of them, so that is 4C2. Alright. Anyways, it's multiplied to 6. So the final answer goes to 360 over 1001. It is an odd word answer, but it is the correct one. Alright, 360 over 1001 after simplification. Alright, this is part A. Alright, so let's recap what we did in part A. Number one, right? They are taken at the same time. This is important, alright, at the same time. Right. Number 2, don't think about yellow or white. Yellow or white, they are just one color. We call them non-red. Right? There are 2 colors, only 2 colors in this box, red and non-red. That's number 2 important thing here. Number 3 is the blue number here. Alright, the blue number is the number of times this branch is going to repeat. Right, this branch is going to repeat. Alright. So part B, we want to find the probability that at least 2 of them they are red. So you just repeat part A several times, right? Let me switch to purple, right? In part B, the probability of at least 2 reds, alright? There are 2 ways you can understand it, right? You can do it in the purple way. At least 2 means there is exactly 2 red, or there are exactly 3 red, or there are exactly 4 red. Alright, so you just repeat part A 3 times. You just did exactly 2 red. That would be 360 over 1001. You do it again for 3, for 4. You add them up together. Alright. Or alternatively, you can do this. You can use unless. Alright. Unless there is only 1 red or no red. Alright. Or no red. So that would be the probability of 1 minus exactly 1 red or exactly 0 red. Exactly 0 red means all 4 of them they are non-red. Alright. So you need to calculate this one, exactly 1 red or 4 of them they are non-red. Alright. So whether the purple way or the orange way, you still have to do calculation of 2 probabilities. Alright, because in the first one you already did that in part A. Alright, so there's no relative advantage in the purple one or the orange one. I suggest you try both methods, right, to see whether you come to the same answer. And that answer is 5 out of 11. Alright, see whether you come up to the same answer. Alright, to test for the understanding. Okay, so this is it for the first part of the past paper questions.